Saxon Algebra 1, Lesson 63. Welcome, welcome. Greetings to my students. We have got a fun lesson today. It is a two-parter, but I'll tell you what, the second part is just something I need you to memorize, so it's not a big deal. What we're going to talk about first is the products of square roots, I should say rule right there. And this is going to bring us to one of my favorite metaphors in all of algebra. It's the three pigs radicals rule. Okay, here's the thing. You guys know the story of the three little pigs. There were these three little pigs. They set out on their adventures. They each built themselves a house, one of straw, one of sticks, I think, and one of bricks, right? And then fates befell them, terrible things. The big bad wolf came, started blowing down houses, and they ended up living back together in the brick house, right? Because of all the huffing and puffing that was going on. So here's what we know about those pigs. They're highly adaptable in terms of their housing arrangements. They can live together, they can live apart, and they're quite willing to flex and go with whatever they need. That's what I want you to see in this product of square roots rule. When we're multiplying different square roots together, they're like the three little pigs. They can live separately or they can move in together. They're fine with it. And conversely, this works in both directions. And sometimes we need it one way and sometimes we need it the other way. We can pull them apart if we want to as well. They're highly adaptable in their housing arrangements, and that is lovely for us in terms of math, but it also just reminds us of this three little pigs thing. Now, let's look at an example of how we can use that. Simplify the square root of 50. Now, when we have a number inside of a square root sign, we can always consider it to be a combination of factors, right? And so what we want to do is not necessarily put them in separate houses, but we want to figure out how many factors this can be. So what we do is a prime factor tree of whatever's inside of the pigs, right? So I'm going to say 5 times 10. 5 is a prime number. 10 breaks down. So 5 times 2. So we can rewrite this if we want. Later I'll show you how you can do a lot of this with less note taking. You can say that the square root of 50 is the square root of 5 times 5 times 2. Makes sense? These are the prime factors of 50, so we can rewrite 50 as these three factors. Now, here's a rule that has strong math underpinnings, and I can explain it to you that way. But for every 2 pigs in the house, you can bring 1 pig out of the house. Think of that as they know there's danger out there, and they would never go out alone. So that you're always going to send your pigs out in pairs. But once they get outside, there's only one of them. So the final answer to this problem is 5 times the square root of 2. We simplified it by breaking it down into its prime factors and then bringing out pairs of pigs. 2 on the inside equals 1 on the outside. So this is our final answer. Right? There's the 2 that was left behind. Huh. Okay. This, and P.S., this we can also really easily prove by doing something like this. Square root of 16, we know that's 4, right? But we could also take this and write it as the square root of 4 times 4, because 16 is 4 times 4, right? I didn't even get it all the way to its prime factors. But now you can see, oh, look, a pair of pigs on the inside equals 1 on the outside. And that just proves the cockamamie thing I told you about the pigs being scared to go outside. But you'll remember it. It's okay. Example 63.2. Square root of 200. Okay, so we have to start thinking in terms of factor trees. Again, let's do 20 times 10. Okay, you guys just go ahead and work this, and then we'll compare in the end. Okay. And then write them all in order once you get them done. All right. Look and see if your answer looks like mine. I'll give you a minute longer to breathe. So we've taken 200, we've written it as a string of prime factors. Now we can circle pairs of pigs. There's a pair of 2s. Then there's one more 2, but we can't use it. And then there's a pair of 5s. So we're going to hop out a 2 pig and a 5 pig. We'll multiply them together to get a 10 on the outside. And then we're left with just a single 2 on the inside. And that's the right answer. Yay, this is also the right answer. So prime factoring is now not something that we do for its own right. We do it as part of another problem. Huh, cool. All right, 63.3. There are 4 of these problems, by the way. Gracie's mad at me because one of my daughters is making cookies in the kitchen. I can hear the mixer going. And Gracie can hear it too. She really wants to go out to the kitchen and try to mooch food, but I won't get up and open the door for her. So she's trapped. Sorry, lady. Square root of 147. Ugh. What are we going to do with this monster? It doesn't end in a 2. It doesn't end in a 5. It doesn't end in a 0. I don't know what multiplies to make 147, but I remember we have one more trick up our sleeves. If this is divisible by 3, then these digits ought to add up to 3. 1 and 4 is 5, 5 and 7 is 12, 3 goes into 12, good. Okay, so I know it's going to be 3 times something. So let's go over here and do 147 divided by 3 and see what we come up with. That would be 4 times for 12. Aha! 3 times 49 is 147. Well, 3 is prime. 49 is not, but I know that one. Right? So, we can rewrite this as 3 times 7 times 7. It really helps if you put these in order and make sure you have any matching factors written together because, again, you're looking for those pairs. So we'll hop 2 7s out. They'll become a single 7 on the outside, and then we've got that left over. Simplifying radicals is a fairly satisfying process. And then here comes the last one because John is beating this into our heads physically. Okay, this one's square root of 108. I'm going to let you guys work it by yourself. Pause me, work it all the way through, then start me back up, and then I will write it out without even talking. All right? So pause me now. Okay, now you're back, and I will work it without talking about it. Yay! Final answer. I hope you got that too. Remember that when we take the pigs and we hop them out, if there's more than one pig, we multiply them together. That's how I jumped out a 2 and a 3, and so 2 times 3 is 6. We don't add them. Remember, we're multiplying all of this stuff together, so it makes sense that we multiply the pieces on the outside too. Don't add them, multiply them. All right, beautiful. That is the gist of our lesson. There is one other topic, These are some repeating decimals that are very common, and what John wants you to do is just memorize them. For example, this one I'm sure you already know. 1/3, if you divide that, you'll get 0.3 repeating, which is the same as 0.333. Yeah, that. Memorize, you don't have to memorize that. Memorize this much of it. I'll draw a box around. There's 4 of them. 2/3 equals 0.6 repeating. 1/6 equals 0.16, and just the 6 repeats. And then the last one is 1/9, and that is 0.1, and the 1 repeats. Okay, so you want to memorize these 4 facts. Okay, 1/3 I think you already know. 2/3, well, you just double it, right? 1/6, look, there's the 1 and the 6, but just remember that only the 6 repeats, and then 1/9 is just 1. Okay, so that's not too much, but just memorize those, because that way you don't have to calculate them every time you run into them. Yay, lesson 63 is done. Congratulations, I'm very proud of you. Remember your story about the 3 little pigs. We're going to build on it for many, many lessons to come. We'll get to know the pigs quite a bit. I mean, you already know them. We're just going to spend time with them. Quality time. Okay, goodbye. I'll see you for 64.